This is the question that we're going to go through. Pause the video now and have a go at the question yourself. So let's get started. A particular medication takes on average 10 minutes to start working. So our average is 10. Assuming that the onset of this medication follows a normal distribution, standard deviation of 2 minutes, find the time below which the drug begins to act in 5% of the patients. Okay, so let's just get some things written out. X, we'll call that time, or we can write that as t, but I'm going to write that as x. Can be normally distributed with the mean of 10 and standard deviation 2. Let's quickly draw a graph to represent what this would look like. Our mean over here would look like 10 and look something like that. And we're trying to find the time below which the drug begins to act in 5% of the patients. So we're looking on the left hand side. We're looking at the time it takes for the drug to work in this 5%. So they say that this is the bottom 5%. So it has an area of 0.05. And a quick way we could find this out is if you go into your calculator. If you have the 9 on 1x, just go into distribution, inverse normal function. You can put the area as 0.05. The standard deviation for us is 2. And our mean is 10. And that will give us a time of 6.71 minutes. So anytime below this, the drug is working in 5% of the patients. And you can also work this out using your z using your equation for z and your z statistic and so on. Okay, let's go on to the next question. A patient is given this medication, given that the drug took less than 10 minutes to take effect. So firstly, given, we're thinking about conditional probabilities when we see that. The drug took less than 10 minutes to take effect. What is the probability that it actually took more than 6 minutes? So we're trying to find the probability that our drug took more than 6 minutes to kick in, given that our drug took less than 10 minutes to kick in. And that will look something like this. Okay, so according to our conditional probability equation, this is equals to the probability of the intersection of these two probabilities. So that will be our x is greater than 6 and it's less than 10. So it's in between them, divided by the probability of our time taken for the drug to kick in being less than 10. Okay, so we can kind of make a bit of sense of this using graphs. So if this is one curve over here, I'll zoom in. The probability on the top of our equation over here will be somewhere over here, because this is 10 and we'll just say this is 6. That's like our intersection, and we're just trying to find that over all of this, which is effectively half of it, because anything below the mean counts for 50% of the data. So we can work this out in our calculator quite easily. Go to normal CD and our lower bound is going to be 6, our upper bound is going to be 10, our standard deviation is 2 and our mean is 10, and that gives us an answer of 0.477, and then we divide that by 0.5. Okay, so I'm just going to rub these out. Therefore our answer is 0.954. That's our answer to this question. Okay, we'll go to the next one. Given that the drug took more than 6 minutes to act, what is the probability that it actually took less than 10 minutes? So this is kind of the opposite. So what is the probability that actually took less than 10 minutes, given that it took more than 6 minutes to act? Now that'll be the same, that'll just be the probability that x lies in this interval, and we sketched it just above there a minute ago, but now it's going to be over the probability that x is greater than 6. So how do we find the probability of x being greater than 6? That's going to be the probability, that's going to be 1 minus the probability that x is less than 6, because we're looking on the left hand side of these normal distribution curves, and that is 1 minus 0.02275, and this gives us a probability of 0.977. So that is just going to be what we got up over here, yeah, 0.477 over 0.977, which equals 0.488. So over here we've got the answers to two conditional probabilities, and we had to use a bit of our normal distribution skills. Okay, so that is it for the video. Thank you for watching. Let me know if you have any questions at all.